Okay, what about this? Which one is bigger, the one on the left or the right?
Right.
The one on the right, because this 5 is bigger than that 0. And then this one. The one on the left is bigger because they match. Everything is the same up until you get to this. After this third 2, you have a 7 here and an 8 here. So this one's bigger. And what would happen if these were both negative? This answer would flip, okay? You're supposed to place these in order from smallest to largest. So we'll just do this together here. So let's see if we can't figure out, someone volunteer, what's the smallest number on this list? 3 point, wait, I don't see.
Is that 3 or 5?
Where? This is a 5.
Okay, so
Yeah.
4.1.
4.109, everyone agree? So that would be the smallest one we have. Okay, let's move on. Someone else? Not all at one time, please. Raise your hand. What's that? 5.42. Do we all agree that this is the next one? Yes, okay. Okay, who's got the next one? 5.532. Good. How about the next one? Go ahead, Chris. 5.760. Yeah, and that's because these are pretty much the same, except this one has a 0 after the 6, this one has a 9. That one over there too, right? Has 5.76. This one has a 1. This one should be next. So 5.7612. And we have 2 more. 5.7694. And finally 7.001. So that would be those order from smallest to largest. Okay, any questions? Those are the first 2 sections. Let's just take a look at the third one. How are we doing on time? It's 1:30. Let's take a look at this last section. I told you these would be quick sections, right? Okay, so now, converting fractions to decimals. Get your calculator out. I said you can have your phone today. It's easy to convert fractions to decimals if we have a calculator. If we do not have a calculator, what do we have to do? Good old long division like this. 1 divided by 4, you'd have to put 1 in here, 4 out here. Then you say, oh, 4 doesn't go into 1, so you do a decimal point, bring a 0 here. 4 goes into 10 twice, so you point 0.2. Does this look familiar? Okay, we don't need to do that. Okay, 1 divided by 4. 1 divided by 4. Up, you did the other way around. 1 goes divided by 4. 0.25. 0. So we're going to put 0.25. The calculator is going to probably say 0.25, but I'm going to always put the 0. Make sure that you get this on your calculator because you can do division wrong if you do it backwards. I think that's what you did. You typed the 4 first, then divide by 1. It's always the top number first, then divide by the bottom number. Okay, so on our calculators, let's do 12 divided by 25. Is there a question? 1/4? Let me zoom in on this a little bit. Sorry, does that help a little bit? Okay. This one is what? 0.48, so 0.48. And that's where it stops. There's no decimals after the 8. Okay. What about this one? Do we care that there's a negative sign in front? No, just ignore it. Do 19 divided by 500 on your calculator, and then just make your answer negative. So who has that one for me? Okay, so negative 0.38. Is that what you got? Oh, 0 in front of the 3. Is that what you said? That's what you said, right? I didn't write that down. Okay, so this is just calculator exercise here. That's all it is. Okay, do we need to do those?
No.
Everyone feel comfortable you could get this on your calculator? Okay. Oh wait, you know what? Let's do this last one. The last one's somewhat interesting. You get 2 point what?
72.
Yeah, so this one's different just because you get a number bigger than 1. Bigger than, yeah. You have a number to the left of the decimal point also. Okay, this one, the planet Mercury is roughly 2/5 the size of Earth. Write the fraction as a decimal. So you just go 2 divided by 5 on your calculator, and you should get 0.4, all right? Okay, what about going from mixed numbers to decimals? Mixed numbers to decimals. So there's a couple of ways to do this, but I'll show you the fastest way, all right? You ready for the fast way? All right, what you do is you have to realize that this really means 7 plus 5/8. That's what that really means. So here's what I suggest you do on your calculator. Okay, on your calculator, do 5 divided by 8 first, and tell me what you get for that. We're going to do this first. 5 divided by 8. You get 0.6 what? 25. Okay, now what do you still need to do with that? Add 7, right? So all you're going to do is just put a 7 in front, 7.625. Does that make sense? Because you're going to add 7 ones to it. So add 7 and you get 7.625. Okay, this one, same story. Let's do that on our calculator. What's 9 divided by 20? 0.45. And then we need to add 208 to that, right? So 9 divided by 20 was equal to 0.45. But then we need to add 208 to it, but make it negative. So negative 208.45. Do y'all understand what I'm doing here? Yeah. Just getting the fractional part with my calculator, adding the whole number that's in front, and just keeping the sign of whatever it was. Again, does that seem straightforward to you?
Yes.
Yeah, so like if the 0 was like a 1 and then you added it, that would make it 209, is what you're saying?
If I add 1,
Like if that 0 was a 1. Like I'm not like saying that problem, but say if it came out, answer came out.
oh yes, okay, so yeah, that's a good point to bring up. If this was 1.45, we would add 208 to that. But the issue is when you write a mixed number, you never have this number on top bigger than this one. Like that'll never happen because anytime you write a mixed number, you're never supposed to have this bigger than this, which would make it bigger than 1. So you don't need to worry about that, but that's what you would do. Yeah. Okay, I think y'all can handle those? Same thing? Okay, there are some fractions that when you write them as a decimal, you get what's called a repeating decimal. A repeating decimal. It goes on forever. All right, so if you try to do this, let me do this the old school way. 1 divided by 3. 3 doesn't go into 1, so I'd have to put a 0 here, like this. And then I put a decimal point. I say, how many times does 3 go into 10? And I say 3 times. Multiply 3 times 3 is 9. And then I carry down, I subtract, and I get 1 left over. And then I bring another 0 down, and then 3 goes into 10. How many times? 3. And what happens is we keep on getting this happening over and over. And so you just get 0.33333 forever, right? We call that a repeating decimal. So the way we write it is you write 0.3 and then with a bar over the 3, and that just tells everyone that 3 really goes on forever. And if you try this on your calculator, 1 divided by 3, it's going to go 0.333, and it's going to stop. It's going to stop because your calculator has to stop it at some point. Some fractions are like that.
So
Not all of them.
Would you count it wrong if like somebody put like 0.333 three, then the bar.
Okay, so the question is, can you do, and then the bar? Yes, that's correct. You could do that. You could do that. The bar over both numbers. The bar is telling you what repeats. Like, for example, if you write this, what that really means is 0.45555 forever. Make sense? But if you write 0.45 with a bar, that means what? 45, 45, 45 forever. Yes? Okay, let's try one of these. All right, so first on your calculator, 7 divided by 9. What do you get when you get 7 divided by 9? 7, 7, 7, 7, 7, 7, 7, forever?
No, it has an 8 at the end.
So your calculator rounded.
Yeah.
Your calculator rounded. So you're allowed to use your calculators, but you have to recognize, everyone needs to recognize that that's a repeating decimal on your calculator. Okay? So we would actually need to write this as this right here turned into what? 0.777 repeated, right? That's what that is? And then what do you still need to add to it? The 4 that's in front. So this should be 4.77 repeat. So see how I put here 77 with the bar, but here I put, 777 with the bar, and here I put 77 with the bar. See, they're the same answer. Okay? All right, let's try this one. I tried to erase that line. Come on. All right, 45 divided by 22. Is that a repeating decimal?
0.488.
So you got 0.488888 forever. Okay, so bar on one of the 8s. And then what do we, oh wait a minute, you should have had something in front.
It's
2 point?
2.45.
Oh, you got something different.
2.045.
I mean, yeah, 2.04.
2.045, just,
Yeah.
It is 4545.
oh, 4545 repeating. Yeah?
So it says 5.
Let me see.
5, like right here.
Yeah, it rounded that last one.
Oh,
It rounded it. What it did is 4545, and then it went like 4, 5, and it rounded this one by looking to the right and saying, oh, that's a 5, so I round that one up to a 5. But you have to recognize that it's a repeating decimal. So put a bar here, and you're done. Does that make sense to everyone?
Yes.
Are you sure? No questions?
Yes.
Okay, so we'll do one of these. We're going to convert this fraction to a decimal, and then we're going to round that to the nearest tenth. So somebody on their calculator do 3 divided by 11. Tell me what you get. 0.027777 repeated?
No,
So 27.
27.
Oh,
It's 0.2, and then 27 after that.
27, just 27, 27, 27. Okay, 27, 27. And it repeats, right?
Yes.
But we want to round that to the nearest what?
10.
10. So we're combining what we did in the past section with this. So now to round this to the nearest tenth, we underline the tenths position. We look at the number to the right, which is a 7, which means the 2 is going to go up to a what? 3, and everything else is zeros. So 0.300. We don't have to put them. We can just put like 1 or 2, and we're good.
You don't need to put a repeating with this?
It does repeat. You don't need to put a bar. Think you could do that one? 2 divided by 7 on your calculator?
Negative
Negative
0.28.
28. Does it repeat?
It says 5. 2.85.
think 0.2857142. That's not repeating, is it? Wait, 28, say it again. 7 1?
142.
Okay, so we need to round to the nearest what? Thousandths, tenths, hundredths, thousandths. We want that one, right? So we look at the number to the right, which is a 7, which means we're going to take that 5 and turn it into a 6 and leave everything else alone.
So no matter how long that number is,
You're going to just stop at the position you're interested in. So like even here, like we didn't have to put a bunch. We just had to put enough to get. You need to be able to see the tenths and the digit to the right of it so you can do the rounding. This okay? Okay. So that's the end of the section. I have one more thing for you, and we will call it a day. I think that's pretty early, right? We're 45 minutes ahead right now. So I want you to think about this number. 0.999 repeated. So I'm going to draw a number line. Here's the number 1. Here's the number 0. Where's that number? Right by the what?
The 1.
Right next to the 1? So like here's the number 1, right? 0.999 forever is the number right next to 1. Does that seem to make sense to you? Yes? Does anyone have a disagreement with that, or does it make sense that that would be the number right next to 1? Yeah? Seems reasonable? Okay. It's not. Let me show you. Okay? So I'm not sure I'm not sure if everyone will follow this. And you won't be tested on this. I just think that this is interesting, and I'm letting you go early already, so bear with me. Okay, let's take that number, all right? Before I can even do this, let me just ask you this basic question. If I asked everyone in here to do 3x plus 4x, does everyone know what that would turn into? 7x. I thought you said 0x. I was like, oh, maybe I should stop. Okay, 3x plus 4x is 7x. Y'all agree? Okay. All right, everyone. I'm going to call this number x. All right? I'm going to call this number x. All right, next thing I'm going to do is what we're allowed to do with any equation, and that is multiply both sides by any number. So I'm going to multiply the left side by 10 and the right side by 10. So I'm going to go 10 times this x. That must equal. Now, what happens when you multiply a decimal by 10? Do you all know what happens to the decimal point?
it moves over.
It moves over. Yeah, so think about it this way. If you had $3.45, right? And you multiply that by 10, how much money do you have? You have $34.50. The decimal point moves over. So everyone here has to agree with the fact that when you multiply a number by 10, the decimal point moves to the right one position. Can you all believe that and agree with that? Okay. So if I multiply this by 10, this decimal point moves 1 over, and now I have 9.99 forever still, right? Those 9s keep going? Okay, now what I'm going to do is I'm going to ask you this. What is 10x take away x? Just tell me what that would be. If you have 10 x's and you take away 1x, how many x's would you have? You'd have 9 x's, right? Y'all agree with that? But what was 10x over here? 9.99 forever, right? What was x over here? So I'm going to subtract from it 0.99 forever. What would happen if you take 9.99 forever and subtract 0.999 forever? You just get 9, because all this stuff to the right would all go away, wouldn't it? So you just get 9. So 10x minus x should be equal to this minus this. But that means 9 times x is 9. What number do you multiply 9 by to get 9? 1. This would mean that x has to be what? 1. So what am I saying? I'm saying that the number 0.9999 forever is not the number right next to 1. I'm saying it is the number 1.
got it.
which is really strange.
Yeah.
The number 0.999 repeated forever is actually the same as the number 1.
So basically, if it was like 9.1, would you need to keep it right next to it? Or would it
9.1?
like, you know how like, say like, you have a temperature of like 99.1,
Uh-huh.
0 something? Wouldn't that be like right next to like 100, or wouldn't that?
It would, but here's kind of, if you're going to take anything away from this, here's what I want you to take away. There is no number closest to 1. It doesn't exist. So it goes back to the whole thing about the darkness in the sky and the stars. The number 1 is a star, okay? And it is impossible for you to find a number closest to that star, because as soon as you think you've found it, there's a bunch of black empty space in between, and all of that space are actually numbers. So it's not like counting 1, 2, 3, 4. As soon as you include everything, it's impossible to be right next to another number. It's very strange, but that's the way the numbers work. Okay, so your homework for tonight on Alex, and I'm not sure on the due dates on these right now. 1.4, 5.1, 5.5? Yeah. 1.4, 5.1, 5.5. All right?
Yes.
Okay. Everybody have a good day. I'll give you your test back next time.
Yeah.
Yep, have a great one.